Also, we've been asked to describe the acceleration of the car for each part of this journey. So let's come back up to our speed time graph, okay? Now, what is the definition of acceleration? Well, acceleration is just simply how quickly you're changing speed, okay? If you're driving along in a car and if you accelerate sharply, it means you're changing speed really quickly, okay? If you accelerate slowly, it means you're not changing speed as quickly, okay? So we can say then that the acceleration is just equal to how quickly your speed changes. So change in speed for every change in time. So if we refer that back to the graph, I can see that from our speed time graph, we're doing three distinct things with our speed. For the first 20 seconds, we're accelerating, right? Because our speed is increasing from 0 to 25 meters per second. Then from 20 seconds to 60 seconds, we stay at a constant speed of 25 meters per second. And then from 60 seconds to 100 seconds, our speed decelerates, or we're decelerating, so our speed is getting less. So it's going from 25 to 0 over the course of those 40 seconds, from 60 seconds to 100 seconds. So if you just put into words exactly what I've just said, that will get you your full 2 marks. You could, if you wanted to as well, work out the gradient of each part of that graph. Because are you happy that from this formula, we're just doing change in speed? So change in speed, for example, for this first bit, would be that distance there. So from 25 to 100. Okay, so that's for the first 20 seconds. How much is our speed changing? It's that distance there. That's just a triangle, isn't it? When we divide the change in y divided by the change in x, that gives us our gradient. So you could work out the gradient if you wanted to. And if you wanted to do that, you do 25. So for this first part, you do 25 divided by how many seconds are we changing? We're changing by 20 seconds. Okay, so 25 over 20. To my eye, it looks like 5 over 4. And then for this second part, what's our gradient? Well, our gradient isn't changing at all, is it? You know, how much is our y value changing? Well, it's not changing at all. It's just a flat line. So it's going to be 0 over 40. So 0 over 40, which just comes out as 0. Okay, because of course that's our change in time. Again, if we wanted to work out the gradient for the last section of the graph, we do our change in y. So our change in speed is 25. Okay, divide that by a change in time. So our change in time is 40. So it's 25 over 40 again. So it's the same as the first part of our graph. So it's not the same as our first part of the graph, because our first part of the graph is over 20 seconds. Apologies for that.